Hello, everyone. This session is for those who want to improve their car's handling performance or are interested in vehicle tuning. Today's topic is bushings. We'll take a closer look at the role bushings play in a vehicle and how they affect ride quality and handling. This video focuses on theory, so it may feel a bit technical, but I made sure to include only the essential points you really need to know. If you enjoy this kind of content, I'll continue producing more tuning-focused lessons in the future. Let's start with a real example. The image on the left shows the suspension layout of a BMW M5, and the arrows indicate where bushings are installed. The image on the right displays different types of bushings used in actual vehicles. Bushings connect the control arms to the chassis, absorbing shocks and vibrations so they're not transmitted directly into the vehicle. They also allow smooth movement while maintaining proper alignment between components, helping keep the structure stable. The left image shows the basic construction of a rubber bushing inner and outer metal sleeves with rubber in between. Since the 1950s, rubber bushings have become widely used because they are inexpensive to produce, effectively absorb vibration, require no lubrication, and their stiffness can be adjusted to tune suspension characteristics. Simple yet highly functional rubber bushings have been the standard choice for decades. Now let's look at the limitations. The left image shows a car leaning outward during cornering. As lateral forces build up, the bushings deform under load. In the right image, you can see that the rubber compresses, causing the inner sleeve to move outward. This movement is called bushing deflection. While slight deflection helps comfort in daily driving, at the handling limit it can delay steering response and make the car harder to control. So how does this affect handling? In the top left image, the front wheel is upright, maximizing tire contact with the road. But under cornering, deflection pushes the control arm outward, the tire tilts outward, as shown in the bottom left image. This reduces the contact patch and decreases grip. The right image shows the same effect at the rear wheels. Camber change may reduce traction and cause understeer or oversteer. This phenomenon is called camber loss. Bushing deflection can also influence steering characteristics, depending on the placement of the tie rod. On the left, the tie rod is positioned behind the steering axis. During cornering, deflection pushes the arm outward, causing the wheel to steer more than the driver intended, generating oversteer behavior. On the right, when the tie rod is in front of the axis, the arm is pulled inward under the same condition, and the wheel turns less, leading to understeer. Now the rear suspension. Under acceleration, the rear control arm is pushed forward, increasing toe-in and causing understeer. Under braking, the arm moves rearward, increasing toe-out and leading to oversteer. Even without steering input, tiny changes in rear toe due to bushing deformation can noticeably alter handling behavior. Different suspension layouts exist, but the same principle applies. Bushing location and force direction matter. Are there alternatives to rubber? Steel bushings are one example. They have almost zero deflection, providing sharp and immediate steering response. However, they transmit all vibration and noise, require precise machining and regular maintenance, which makes them unsuitable for most street applications. Urethane bushings are stiffer than rubber but more compliant than steel. They look rigid and precise, but unlike rubber, urethane can't easily absorb twisting motion. As a result, the bushing must slide against metal, and without proper lubrication, it can create noise or stiction. So while stiffer, urethane sometimes performs worse in rotational applications. Next is the nylon bushing. When assembled with metal sleeves, it allows very precise rotational movement. Some designs include grease fittings, greatly improving durability with proper maintenance. Where accuracy of movement and pivot location is critical, nylon can be a better option than urethane. Finally, spherical bearings. The image on the left shows their structure. They allow free rotation and articulation in multiple directions without changing pivot length, eliminating unnecessary deformation found in rubber bushings. That's why they're widely used in racing applications. The image on the right shows a tuning part for the rear suspension of a BMW F20. For maximum response on winding roads or on the track, this is the ultimate choice. The downside: expensive, demanding installation accuracy and maintenance isn't easy. Today we explored the deep world of bushings, small parts that have a huge impact on how a car feels and handles. Depending on whether you prioritize winding road agility, track performance, or high-speed stability, the ideal bushing choice will differ. If you want truly precise handling, bushings are a critical part of the equation. More tuning-focused content is on the way, so if you found this video helpful, please support the channel with a like and subscribe.